Hey guys, so today I've got my hands on the exam paper from today, the paper 2 calculator paper for AQA GCSE at Foundation. I'm going to be having a look through, seeing what the answers were so you can see what you got right or maybe use it for revision in the future. Okay, so write 0.27 as a fraction, so that's going to be 27 over 100. Write 2/5 as a decimal, 2/5 as a decimal is the same as 4/10, so that'd be 0.4. Here's a calculator paper, so I could have just put that in and pressed to change it to a decimal. Write 0.35 as a percentage is 35%. Nice and easy so far, hopefully. Simplify fully. X plus 4x is 5x. 5 times 2w is 10w. 2m divided by m would just be 2. Y times y times y is y to the power of 3. Here is a quadrilateral. Write down the letter of the obtuse angle. So the obtuse angle is C. An acute angle. D is an acute angle, but we could also have A there for an acute angle. How many lines of symmetry does the shape have? No lines of symmetry. One lettuce costs £1.29. How much do 7 of these lettuces cost? So that's going to be 7 lots of £1.29. So 7 times £1.29, £9 and 3 pence. So 903. They've got the unit there for us. 5 cucumbers cost £6.40 in total. How much do 2 of these cucumbers cost? Well, let's do £6.40 divided by 5 to find out what 1 is worth, and then take that and times that by 2 to find out what 2's worth. So £6.40 divided by 5, £1.28. It's quite expensive for a cucumber if you ask me. So £1.28 times 2, £2.56. A company sells 3 types of bottle. The pictogram shows how many bottles they sold 1 week. One of these blocks represents 20 bottles. Okay, the company sold more plastic bottles than glass bottles last week. How many more? More plastic than glass. So they're the ones that are more plastic than glass. So 20, 40, 60. The company sells each steel bottle for £17.50. Work out the total amount of money made from selling steel bottles that week. So 20, 40, 60, 80, 100, 120. And then that must be worth 5. So that's 125 bottles at £17.50 a bottle. Grab the trusty old calculator. 125 times £17.50. 2187.5. Need to be careful here and remember that money's always given to 2 decimal places. You'd never see 0.5 in a shop. Well, you do see it outside some shops now, but it does drive me mental. Shape ABCDE is drawn on a centimetre grid. Complete this statement. AB to something is 5 to 1. Well, AB is 5, so I'm looking for one that's 1. So that'll be DC. On this centimetre grid, draw a rectangle with the same area as the shape. So area of the shape, we could just do it by looking at squares. So 1, 2, 3, 4, 5, 6, 7, 8. Those 2 together would make 9. Those 2 together would make 10. So let's have a 5 by 2 rectangle. Don't write in your exam with a pen like this. Don't draw, rather, I should say. It just helps it come up nice on video, and I should, of course, use a ruler. But we're just having a look to see what we should have done. use a ruler for this question and every question. Here's an accurate drawing of an equilateral triangle. By measuring, work out the perimeter of the triangle, state the units of your answer. So, rule the world. I'm going to be picky with this. 7.4. So I'm going to say that's 7.4 centimetres times 3, because it's an equilateral triangle. So 7.4 times 3, 22.2 centimetres. They didn't say to round it to any amount of decimal places, so I'm going to leave it to 1 like that. There are 56 cubes in a box. The cubes are green, red, blue or white. 17 cubes are green. There are an equal number of red, blue and white cubes. How many red cubes are there in the box? Well, that's our 56. Take away the 17 that we know about. And then because there's the same amount of red, blue and white cubes, we'll be dividing that by 3, won't we? So 56 take away 17 equals, divided by 3, 13. 24 more cubes are added to the box. A cube is picked at random. The probability that that cube is green is 0.4. How many of the 24 cubes added to the box are green? Well, I did have 56 cubes right at the very start of the question, and now I've got 24 more. So let's do 56 plus 24 to find out how many cubes we're talking about. Do everything on the calculator. It's a calculator paper. So that's 80 cubes. So I know my fraction is out of 80. And I know that's the same as 0.4. Well, that's the same as saying that x over 80 is equal to 0.4. So I'll just solve this and times by 80. So 0.4 times 80 equals 32. So that tells me that there are 32 green ones. Now, 32 is too many because there was only 24 added, but 17 of the cubes were green to start with. So let's do our 32 take away 17 to get the amount of green ones that were added. So just taking away 17 there from our 32 to get 15. 15 green cubes were added out of the 24. An electric car uses 1 unit of electricity to travel 3 miles. 1 unit of electricity costs 50 pence. There's always something in there, isn't there? There's always something. Work out the cost of electricity in pounds to travel 270 miles. Well, I can go 3 miles on 1 unit. So let's do 270 divided by 3 to find out how many units I want. Calculator paper, we could do this quite easily without a calculator. So that's 90 units at 50 pence each. So that's 90 times 0.5 for our 50p, which would be £45. If you are doing your exam, do everything on a calculator. You can make silly slips in situations like that, so do use your calculator. Lima buys 2 metres of linen at £8.50 per metre. She also buys 5 metres of cotton. The total cost is £38. What is the total cost of 1 metre of cotton? Well, she's got 2 at £8.50. The 2 at £8.50 is 17 quid. So let's do the 38, which is everything. Take away the 17, which is the linen. 38, take away the 17. So that's 21 left over. The 21 left over is for the 5 metres of cotton. So 5 metres of cotton is worth £21. So for 1 metre, I must divide by 5. 21 divided by 5. £4.20. So £4.20 for a metre of cotton. Buttons cost 65p each. The greatest number of buttons Lima can buy with a fiver is 7. She says the greatest number of buttons I can buy with 10 is 14, because double £10 is, because £10 is double £5 is correct. Tick a box. Well, let's just do the maths. She says that she can buy 7 with a fiver, so £5 divided by 65p. She can buy 7, yeah, well 7 and over half, so it is going to be more. So let's just check that, we'll feel double confident. So £10 divided by 65p is 15 and a bit. So is she correct? No, because our £5 divided by 65p, shouldn't write it like that, don't write it like that. 5 divided by 0.65 for 65p equals 7 point, what was it? 692, and our £10 divided by 65p is 15.38. So she can get 7 there, but 15 there, so she's not correct. Here is a table of values for the equation y equals 3x plus 1. Draw a graph of y equals 3x plus 1 for the values of x from 1 to 4. Again, don't use a pen when you do this. It's just a pencil won't show up very well if I use a pencil. So what have I got? I've got 1 and 4, 2 and 7. So 7's going to be exactly halfway in between there. 3 and 10. 4 and 13, so again 13 exactly halfway in between. Draw our graph, so hopefully you should have a nice straight line, which is going through at 1, which we'd expect, so that looks great. Work out the value of y when x equals 2.5. Well, we could just bang that in the equation, so 3 times 2.5 add 1, well 3 times 2.5 is 7.5, add 1 would be 8.5. Or of course you could get that from reading the graph, so when x is 2.5 it would be there on the graph. So you could read up, read across, hopefully that should be coming out at about 8.5 as well, yeah. A code has 5 different digits written in order starting with the smallest. So different digits in order starting with the smallest. The last digit is the only square number. The middle digit is the only even number. Work out the code. Okay, so well, let's think about this. This isn't our question. The last digit is the only square number, so that's going to be a square number. The middle digit is the only even number, so this is going to be an even number. Well, single digit square numbers are 4 and 9, so it makes sense to put 9 there, because that gives me greater room, doesn't it? If I put 4 there, I've not got enough digits. Excuse me, so I want that to be even, so makes sense for there's the only even number. So can't put 8 there. Let's put 7 there. Only even number, so let's put 6 there. 5 can go there because it's odd and it's not square. 4 can't go there because it's even and it's square. 3 can go there, so it's 3, 5, 6, 7, 9. 4 numbers have a mean of 10. 3 numbers are 5, 8 and 9. Work out the other number. Well, if they have a mean of 10, we added 4 things together, divided it by 10. Sorry, we added 4 things together, divided it by 4. and we got 10. So if we do 10 times 4, that'll tell us what the thing we had was after we'd added it up. So it should add up to 40. So what? 5 plus 8 plus 9 is 22. So 40 take away 22. 18's my missing number. You can always double check that if you want, can't you? By 5 add 8 add 9 add 18 equals divided by 4. Gets me my mean of 10. Shows it's working. Rearrange D equals H minus 4 to make H the subject. So if I want H on its own, I'd be getting rid of that minus 4 by adding it. So D add 4 equals H. Rearrange P equals W over 3 to make W the subject. Well, if I want W on its own, I need to get rid of that. So undo a divide by 3 by times in by 3. So 3P equals W. A linear sequence begins 2, 5, 8, 11. Work out the nth term. So I always do this by saying, what's the gap? The gap is always 3, so it's going to be 3n. What number came before this one in the pattern? Well, that would be minus 1, so it's 3n minus 1. The diagram shows a circle centre O and 3 straight lines. Use one word to describe each shaded region. Region A. That's the one that looks like a bit of Terry's chocolate orange. You have a segment of Terry's chocolate orange. Not sponsored, Terry's, but, you know, if you're watching. Region B is a sector, or if you're American, sector. 17, work out. I've just got some vectors to add up here. So 1 plus 4 is 5. 2 plus 6 is 8. Nice easy mark there. Bag A and bag B contain counters. Bag A, a quarter are red, the rest are blue. Bag B, 3 are white, 2 are green. Complete the tree diagram. So a quarter red on bag A and the rest are blue, so that must be 3/4. 3 are white, so that's 3/5. 2 are green. And then it's the same, isn't it? So 3/5, because that's still white. And 2/5. One counter is taken at random from each bag. Work out the probability that one is red and one is white. So red and white would be that way. So just times in these fractions. So 1 times 3 is 3. 4 times 5 is 20. So 3/20. Use trigonometry to work out the value of x. So label the triangle up first. This is the hypotenuse. This is the opposite, because it's opposite the angle I've been given. So this is the adjacent. Some old hippie caught another hippie tripping on acid. Other versions are available. So I've got the hypotenuse and I want the opposite. So it's going to be the sine triangle I'm using. Because it's the opposite I want, I'll cover that. These two things are next to each other, so I'm going to multiply those together. So 31 for my hypotenuse times sine 24. .6. No degree of accuracy, so I'm quite happy to leave it as that. The mass of an iceberg is 2,200,000 kilograms. This value is a 12% reduction from the original mass of the iceberg. Work out the original mass of the iceberg. Give your answer in standard form. Okay. So, well, the way I think about this is it was 100%, but then it lost 12%. So it must now have 88%. So 88% is equal to our 2,200,000 kilograms. So if I divide by 88, that'll give me 1%, and then times by 100, that'll take me back to the original. So I do the same on this side, so my 2,200,000. Just careful with your zeros there because it's easy to make a mistake. Divided by 88, give me 1%, times that by 100 to give me my whole thing. So what's that? There's the end of my thousands, 2.5 million, so 2,500,000 kilograms. It said give your answer in standard form, so that would be 2.5 times 10 to the power of, right, we'll pretend in the decimals there, aren't we? Sort of what we're doing here. 1, 2, 3, 4, 5, 6. So 2.5 times 10 to the 6. A chef has a tub of blueberries. She wants to use all the blueberries. She puts the same number of blueberries on each dessert. So D equals K divided by B. D is the number of desserts. B is the number of blueberries on each dessert. What does the constant K represent? So something divided by the number of blueberries on each dessert equals the number of desserts. Well, that must be the number of blueberries. Number of blueberries in the tub, number of desserts, number of blueberries on each dessert, not the above. Number of blueberries in the tub. Complete the table. Oh, so it's telling me here that when D is 120, B is 2. So I've got K, which is the amount of blueberries, divided by 2 equals 120. So that tells me that K is 240. We've got 240 blueberries. So all I need to do now is really divide my amount of blueberries by the amount of blueberries she wants to put on a cake. So I've got 240 blueberries divided by 6 on a cake, which would be 40. And, oh, I want 30 cakes. How many blueberries would I use? So I've got 240 blueberries. I put an unknown amount on each cake and I want to have 30 cakes. So that's going to be 240 divided by 30, which would be 8. A fair spinner has 6 equal sections, each with the numbers 1, 5, 6, or... Sorry. Start again, that was awful. A fair spinner has 6 equal sections, each with the number 5, 6, 7, or 8. Each number appears at least once. The probability of an even number is the same as the probability of getting a 7. Work out P of 5. You may use a blank spinner to help you. Right, so if each number appears at least once, let's just bang one of each of them in to start off with. 5, 6, 7, 8. Probability of an even number is the same as the probability of a 7. Now, I've already got 2 even numbers. So I need 1 7 to balance that out. So the probability of a 7, because I've got 2 of them, is now the probability of an even, because I've got 2 of them. Work out the probability of P. Well, the only thing that can go in there now, which is not an even or a 7, is 5. So that is 2 out 6, which is the same as 1/3. A different spinner has 10 sections labelled A, B, C, or D. Give one reason why there might be a mistake, why there must be a mistake, changing the language, why there must be a mistake in the table. Right, well, these things normally add to 1, so let's just see if they do. Doesn't add to 1. Here is a sketch of the graph. Y equals minus 2x plus 6. Complete the coordinates of C and D. Well, C's our intercept, so that's going through at 6, so 0, 6. D, well, this is going through when y is 0, isn't it? So let's say our y coordinate is 0, and that's equal to minus 2 lots of whatever x is plus 6. So if I add 2x, I'll get 2x equals 6, so x must be 3. Here's a sketch of a quadratic graph. Complete the following statements. The value of the y-intercept, well, that's just where we're going through there, so that is 5. The x-coordinate of the turning point T is, so the x-coordinate will be whatever's there. Well, from there to there is 10. So halfway must be 5. So that must be 3. Archie flips a bias coin 200 times. Here is some information about the outcome after each 50 flips. Work out the best estimate for the probability of flipping a head. Give a reason for your answer. Well, the best one's going to be the one with the most flips, isn't it? So I'm going to use these numbers. So answer 52 out of 200, which is the same as 26 out of 100, which is the same as 13 out of 50. Reason, more trials, more accurate. Last question. A lion is sprinting in a straight line away from its den. The graph shows the line's distance from the den. Work out the speed of the line in meters per second. Well, speed equals distance divided by time. So what's the distance? So it looks to me, well, it will come into that mark there. So how much are each of these worth? 5, 10, 15, 20, 25. Yeah, so that's 120 there. Where did he start from? Starting from 30. So 120 minus 30 equals 90 metres. So I reckon the line is covering 90 metres in 5 seconds. And actually the unit helps you think about it, doesn't it? Because it's metres per second. Metres per second. So 90 divided by 5 would be 18. So 18 metres a second. Well, there you go, guys. That's the end of that. I hope that helps.